All right, welcome everybody. So today we are going to explore how magnets work. I feel like Bill Nye with all this equipment and stuff that I've got. You can see I've got a whole bunch of stuff all scattered out across my little table that we are going to test out today. I've brought a big bar magnet, which you might be able to recognize. You can see it's got north and south written on it. So this is a bar magnet. You've probably seen something like this before. And I'm just going to see what happens when I bring this near a whole bunch of different stuff. And I'm going to start out with this compass that's over here, because you kind of have an expectation that the compass is going to do something fun when I bring the magnet near. So here is our compass. And here is my magnet. I think you can see that it pretty well messes with the compass. So not terribly surprising. I've got Baby Yoda here. Baby Yoda doesn't seem to care much about magnets, different kind of force that he likes. I got this plastic acrylic turtle here. Nothing much seems to happen with the little turtle. Got a piece of paper. Nothing much happening with the paper. I do have a paper clip here. Aha! I have found something that interacts with the magnet. So the paper clip seems to have some interaction here. So one thing I want to test is, does it matter whether I use the north end of the magnet or the south end of the magnet? So I'm going to try with the south end because I tried with the north end before. Still looks like it will pick up the paper clip. Cool. I can test the south magnet with the other stuff, but again, you're kind of seeing nothing much is happening with those other things. Oh, I got Baby Yoda here. Test Baby Yoda with the south end. Nope, nothing. Okay, a couple other things. I've charged up this pith ball, which I think you can see kind of hanging here. This was hard to figure out how to do. I'm going to try it out with the magnet. Nothing with the south end, nothing with the north end. So even though I have electric charge on that thing, it doesn't seem to be responding to my magnet. So that's an interesting result for us to think. I got this piece of copper wire here, and whoops, well, we saw something interesting happen there, right? So the copper wire doesn't seem like it reacts, right? The paperclip does, but not the piece of copper. So that's interesting. You might have thought, oh, it's going to be metals or something, but there's some metals that don't seem to do anything. I also have this fridge magnet here, which I just pulled off my fridge earlier today. It's that little black dot there. And that is definitely attracted to the magnet. I want to try again the other end and see what happens. Interesting. It seems like I can do a little bit more with this thing, right? I've got some ability to, here, maybe I'll try. That was attractive, the south end. Let's try the north end here. Interesting. So I was able to push it away first. And then it got attracted to it. So we've got some interesting north-south results on some things, but again, not on paperclip. Let's see, I got another piece of copper here, which doesn't seem to do anything. Oh, I got okay. I got a piece of wood here I want to try out. Piece of wood doesn't seem to care about it. All right, get out of here. I got this thing I want to try out. Worked a little bit. This thing's heavy, right? This was the south end. Let's try the north end. This one seems like it gets picked up by either one, right? I got this piece of metal over here. Looks like this piece of metal gets attracted to the north end. Let's try the south end. Pick it up again, right? Awesome. Let's see, did I try everything out here? I think I did. If you have a magnet on your fridge at home and you want to try this out with something different that I didn't have a chance to play around with, go ahead and go for it. I got one last thing that I can try out. No, I don't. Never mind. I already did that one. I got another magnet here, right? Here's like another magnet, right? Blue and red. This one's blue and silver, right? And again, I can kind of bring these together and see what happens. My fridge magnet's acting up. Let's try that again. These ones are heavy. Let me try the other one. There we go. So I can kind of get a pickup on this one. Let's try the other end. Those ends don't seem to work. In fact, I can get a little bit of repulsion there. I don't know if you can see it. I think you can see it. Push some stuff away. Right, I don't quite have to touch. Oh no, it's probably just Baby Yoda down there. I hope you had a lot of fun with those little experiments, or that you found some of your own to do. But I want to say a little bit about what magnets are and what we can do with them before we start class this week. There's a few different kinds of magnetic materials. We just saw a whole bunch of different examples. Permanent magnets, right? So something like this, or usually your fridge magnet would be a permanent magnet. Those are things that have both attractive and repulsive interactions with each other. There's also ferromagnetic materials, things that are mostly iron, cobalt, and nickel, which tend to be attracted to permanent magnets. Even if they are not magnetic themselves, they'll still be attracted to either a north or south magnet. Most of the other stuff that we tested don't seem to care about the presence of a permanent magnet. We'll see a little bit more about that in one of the later videos. For permanent magnets, there's a north and south pole. I think most people are probably familiar with that idea. They're even labeled on my big magnet. They don't have to be labeled though, as you can see on my little fridge magnet. There's no labels on that. The two poles on the magnet seem to react differently, right? We get like poles repel and opposite poles attract. And again, non-permanent magnets don't seem to care whether it's the north or south. And one thing that you might be thinking right here is, a lot of this sounds familiar, right? I remember when we did electricity, there were two types of charge. Like charges repelled and opposite charges attract. And everything's made of charges, and some of the charges can move around in conductors, but in insulators, they can't. Sounds just like electricity. And so a really, really natural question to ask is, are electricity and magnetism the same? So there's a couple of questions that you might ask. Something like, what happens if we break a magnet in half? You can also ask a question like, how will an electric charge react to the north end of a magnet? We tested that. It didn't seem like it cared. So that's a really interesting result, right? So it looks like there are some dissimilarities between electricity and magnetism. They are not exactly the same. But with how many things that look like they are similar, we might be able to build a similar model for it. So electric charge, here's kind of those four things that I talked about, right? Like charges repel, opposite charges attract, two different kinds of charges. Everything's made of charges, and those charges are differently able to move around. So in magnetism, we already can see two types of magnetic poles, like poles repel, opposite poles, right? We've already got those pieces. So it begs the question, is everything made of tiny magnets? And can we observe any little differences in how those magnets